I think it has started. Yeah. So what I was saying, that for example, for a scalar valued function, the vector of partial derivatives, the vector of first order partial derivatives is known as a gradient vector. Similarly, for a vector valued function, since it is multidimensional on both sides, so the so it's so the so the I mean the first order partial derivatives will definitely be a matrix. Okay, it will no longer be a vector. So the matrix of its first order partial derivatives is known as a Jacobian matrix. Okay, so let's assume if a function f goes from Rn to Rm, then the Jacobian matrix of f is defined as an m cross n matrix. See, you take a note of these dimensions. So the function goes from n to m. So n, so basically it means that x is a n vector and y is a m column vector. Okay. So the Jacobian matrix will be defined as m cross n matrix. So the matrix will be stacked as m cross n matrix, which will be denoted by J, whose ijth element is given by del fi by del j. What does it mean? This means this. So its ith element is nothing. So for example, this first element of this J matrix, it is nothing but the partial derivative of function of the first element of vector y with respect to the first element of vector j. Similarly, this second entry is nothing but del f1 over del x2, which means the of first element of vector y with respect to the second element of vector j. Okay. So this is how we stack a Jacobian matrix. So the rows. So take this first column. So first column is nothing but the let's take the row. So the first row is nothing but the partial derivative of the first element of y with respect to all the elements of vector x. Okay, and the last row is nothing but the last element of vector y, the partial derivative of the last element of vector y with respect to all the elements of vector x. So how do we represent a Jacobian matrix? It is nothing but del f x prime. So this, if you remember that I have told you in the previous class that these notation, I mean where we are writing transpose and where we are not writing where we are not using transpose sign, it is very important and it will tell you how we are stacking the matrices. So for example, in this case, in this first case, in the when we were talking about the scalar valued function and we were talking about the gradient vector, what we were effectively doing, we were differentiating a function y with respect to vector x, and we were talking about the column vector. Hence, what we were doing, what does it effectively mean? That we are going to stack the partial derivatives in the column form. Okay, because we are differentiating it with respect to vector x. So because x is a column vector, because x in column vector, each element is stacked in a column form. Hence, the partial derivatives are also going to be stacked in a column form. Okay. But now here what we are doing. So suppose f is a vector, and what we are saying that we are going to differentiate del f with respect to x transpose. What does it mean? It means that we are differentiating this vector f with respect to the row vector. So what it effectively means that we are stacking the partial derivatives in the row form. Okay. So hence it is del f del x1 del f del x2. Remember that here f is still a vector, so we are further going to uh, uh, elaborate on this. So this is del f del x1 del f del x2 up to del f del xn. I hope this is clear that what I'm trying to say. That since here it is x prime, hence we are stacking it in a row form. And this is how we stack a Jacobian matrix. Okay. Uh, and now since the f is a column vector, so now we have to differentiate the each element of the vector with respect to x1, similarly with respect to x2, and similarly with respect to xn. Hence, these entries are going to be in the column form like this. Okay, so this stacking is very important. That's what I want to convey over here. That when you are saying that del f over del x prime, what effectively it means that we are stacking the partial derivatives with respect to each element of x's in the row form. Okay, del x1, del x2. So del x1, del x2, del xn coming right now here, not in the column. Okay, so please take note of all these things. So now suppose if m is equal to 1, then the Jacobian matrix will reduce to what? So m is equal to 1 means what? That it is a scalar valued function, correct? And x is still a vector. Okay, so then this Jacobian matrix will reduce to a row vector. So this Jacobian matrix will reduce to this first row only. And what it is nothing but the transpose of the gradient vector. It is nothing but the transpose of the gradient vector. Okay, and similarly if m is equal to n is equal to 1, which means if y is also a scalar and x is also a scalar, I mean if the domain and both the range is unidimensional, then this Jacobian matrix will reduce to a single entry, which means that it will be just del f or del f divided by del x, del f by del x. Okay, so this is important. I'm just receiving an important call. Just wait for a minute. Hello. Yes, sir. Sorry. Where I was. Okay. Uh, so I hope it is clear that what is a Jacobian matrix. Jacobian matrix is nothing but uh, a matrix of first order partial derivatives of the vector valued function, and this is how we stack a Jacobian matrix. Okay. So let's see an example of it. So suppose there is a function from R3 to R4. What does it mean? That x is a three-dimensional vector and y is a four-dimensional vector. Okay. And y1 is equal to x1, y2 is equal to 5x3, y3 is equal to 4x3 minus 2x3, and y4 is equal to x3 multiplied by sine x1. Okay. So then what will be the Jacobian matrix in this case? It is nothing but a 4 cross 3 vector, 4 cross 3 matrix. Why? Because the dimension, because m is 4 and n is 3. So it will be a 4 cross 3 matrix stacking like this. The first row is del y1 over del x1 up to del y1 del x3, and the last row, the fourth row, will be del y4 up to del x1 and del y4 up to del x3. Okay, so so we all can do the differentiation. Okay, so if I differentiate y1 with respect to all elements of vector x, so since it is just a function of x1, so del y, so the first entry will be 1 and the next two entries will be 0 0 0 0 and 0. I mean, you guys can do this. I mean, just see this example, and if there is any uh, problem or if there is any confusion, please let me know. So I'm giving you a minute to just see this example, how to stack a Jacobian matrix. And I think differentiation is pretty simple. So the derivative of sine x is nothing but cos x. So this is what is happening here.
Ma'am, is y3 is equal to 4x3 minus 2x3.
Oh no,
Uh,
it is
yes.
minus 2x. It is minus, oh sorry. So the first is 4x2 square minus 2x3.
Okay, ma'am.
I'll correct this. So y3 is 4x2 square minus 2x3. Let me take a note of this. X2 square minus 2x. Uh, so is this clear to everyone? How to find a Jacobian matrix? Okay, so now let's move to another important stuff. So suppose now we'll talk about the set of linear equations. Okay, so this is important. This is important in the sense, suppose if you have a if you have a systems of equation, say y is equal to ax, and if somebody is asking you that what is the derivative of this systems of equation, then how to find it, then what it will be. Okay, so suppose if there is a set of linear equation y is equal to ax, and just notice the notations what I'm using. So, so y is a vector, a column vector with k elements. So y is nothing but y1 up to yk is equal to, and a is, suppose a is a k cross n matrix, and x is a n cross 1 vector. Means x is a vector with n elements, n. Okay, y is with k elements and x is with n elements. Then what will be the dimension of a? It will be a k cross n matrix. Okay, and I am stacking it in a compact form here. So I am saying that A1 is the first row of the matrix A. Similarly, AK is the kth row of matrix A. Okay. So what does it mean? That A1 is nothing but A1, it is a row vector with n elements. Okay. I hope this is clear. So you can see it from here. So I am saying that AI is nothing but the ith row of matrix A. So in a more detailed form, what effectively it means that the first row can be written as AI1, AI2 up to AIN. Okay. So in
Ma'am, what
this,
was X here?
X is a vector with n elements.
All right.
Okay. So Y has k elements and X has n elements. So I'm talking in general sense. I am not talking about a square systems of equation. So what I mean is that I'm not talking about a systems of equation where both Y and X has same dimension. So I'm making it more general. Okay. So effectively what does it mean? That each element of each element of yi of vector y can be written as yi is equal to aix. So this is clear. So we are talking about each equation in this vector, in this systems of equation. Okay. So each element of yi can be written as aix because y1 is nothing but a1. So the first row multiplied by the column vector. Y2 is nothing but the second row multiplied by this column vector, and kth row is nothing but this last row multiplied by the column vector. Correct. So yi in general, yi can be written as aix. So aix means what? ai1, ai2, ain. This is a row vector multiplied by this column vector. What will we get? That we'll get a we'll get summation ai j xj. We'll get a equation. Okay, this is clear. So ai is the ith row of a. So now we have to find the derivative for this systems of equation. So we'll start with the single element, with with a single element of the y vector. Okay. So suppose if we want to find the derivative of this equation, so then what it will be? It will be del yi by del x, where x is a vector. What does it mean? That I am differentiating each element of yi with respect to each element of element x and stacking it in a column form. Okay. What does it mean? What does it mean? That del yi del x1 up to del yi by del xn. If, and what del yi by del x1? Del yi by del x1 will nothing but del I1. See this. Okay. Aix is nothing but the dot product of this vector multiplied by this vector. So it will be ai1 into x1 plus ai2 into x2 up to ain into xn. So del I by del x1 is nothing but ai1. Similarly, del yi divided by del xn is nothing but ain. And what it is, what this is nothing but the transpose of this ai. So this is nothing but ai prime, because ai is defined as a row vector, but this is a column vector, nothing but ai prime. It is nothing but the transpose of the ith matrix. This is del yi del
Ma'am,
x.
you're speaking.
What?
Ma'am, you're not clearly audible. Your voice is very cracking in between.
Is it right now? So what I'm saying that del yi by del x is nothing but ai transpose. And I hope this is clear that why it is ai prime. If it is not clear to me, oh, sorry, if it is not clear to you, then I can repeat it.
Ma'am, this AI in itself is a column vector.
ai is a row vector.
Is a row vector. Okay.
Yeah. So I am using a notation in this way that I am saying that ai is a first row of matrix A, and AK, so see, this A1 is nothing but the first row of matrix A. So what it means that it is nothing but effectively a row vector, because I'm taking the first row. So it is a row vector. This is this vector. It is this vector.
Okay, ma'am.
Okay. So hence del
Ma'am,
y.
one more thing. In order to differentiate the vector y with respect to the vector x, we'll need k such differentiations, right? If I'm not.
Exactly.
Okay.
Exactly.
Okay.
So firstly we have to differentiate so firstly we have to differentiate each element, and then we'll stack everything together.
Okay. Okay, ma'am.
Okay, so this will be next step. Okay, so del yi divided by del y by del x is nothing but ai transpose. Then what will be del y by del x prime? It will be del I, because what I am doing effectively over here, that I am saying that I have to differentiate yi with respect to x, but the stacking is happening in a row form. Okay, so this is clear, right? So now I'm going to use this. Since del yi by del x prime is nothing but ai, now I will move on to a vector. Okay, so far I was talking about a single element of vector y. Now I have to do this for each element of vector y. So for each element of vector y, I am going to stack it in a row form. Sorry, in a column form. So del y by del x prime, then in that scenario will be, so del y by del x prime will be del y1 del x prime, del y2 del x prime, up to del del yk up del x prime, and hence it will be equal to a1, a2 up to ak, which is nothing but a matrix A. Okay. If it is not clear, so let's take this example. So suppose y is equal to ax, and this has to be n. So suppose y is a 2 cross 1 vector, and x is a k. I am taking k or n. So let's assume that y is a 2 cross 1 vector, and x is a n cross 1 vector. Okay. What will be the dimension of A? A will be a 2 cross n matrix. Okay. So I am writing it in a more compact form. So I am saying, so let's assume that A1 is the first row of matrix A, and A2 is the second row of matrix A. So A1 will be a row vector with n elements, and A2 will be a row vector with n elements. This has to be this has to be so A1 is nothing but a row vector with these elements A11, A2, A21. This has to be A1, A1, and this has to be A1n. Okay. And then A2 will be A21, A2, A2n. It has to be A2n. Okay.
Ma'am?
Your voice is not audible.
Yes, ma'am.
I don't know why it is creating problem. I think internet is an issue here. So I am
Yeah,
saying,
ma'am, it's breaking.
uh, I don't know why it is breaking. Uh, if it breaks again, then please let me know, because I don't know what to do, because probably internet is an issue, because yesterday also internet was a big issue. Um, I don't know how to correct this. So I'll repeat this again. So I'm saying, suppose, so let's take this example that y is equal to a of x, where y is a 2 cross 1 vector and x is an n cross 1 vector. Okay. Then what will be the dimension of A? A will be a 2 cross n matrix. So far so good. So now I am writing,
Ma'am, uh,
yes,
there would be like when you expanded A in the last row and last column, it would be A2n, right?
yes, it has to be 2 A 2n. And this first element has to be A1n.
Yes, ma'am.
Okay. So A is equal to, so I'm writing it in a more compact form. A is equal to A1, A2, where A1 is nothing but the first row of matrix A, and A2 is nothing but a row vector, which is nothing but the second row of matrix A. And what are its elements? These are the elements. So this is A1 and this is A2. Sorry. Okay, so this is A1 and this is A2. Okay, so Y is written as, so where y1 is equal to a11 x1 plus a1n xn. So what I'm doing, I'm multiplying these two. So I'm multiplying matrix A and vector x. Okay. So y1 is nothing but a11 x1 plus a1n xn. So multiplying the first row with vector x will give you this first row, and multiplying these elements, the elements of the second row with vector x will give you this dot product, and it has to be a2n. This is a2n. Okay. So now what I have to do, I have to differentiate, I have to find the differentiation of this system equation. What are you doing? I'm trying to find out del y by del x prime. So what it means del y1 up to, so del y1 y del x prime and del y2 over del x prime, because y is a column vector. So the elements will be starting column form, and it is x prime. So the partial derivative with each element of x will be stacked in a row form. Okay. Just we did in the previous slide, like this. So del y is nothing but this column vector, and we have already seen that del y1 by del x prime will be nothing but a1. Okay, this is what we are getting here. So del x prime will be a1, and del y2 by del x prime will be a2, and a1 a2 is nothing but this matrix A itself.
Ma'am, your voice is not clear.
Okay. So I am saying that we have to find del y over del x prime. So del y over del x prime is nothing but del y1 del x prime and del y2 over del x prime in a column form. Okay. And we have seen in the previous slide that del y over del x prime is nothing. Ai means the ith row of matrix A. So we can, and we know that how we have arrived to this thing. So we can use it directly over this del y a1 means the first row of matrix A, and this del y2 over del x prime will be nothing but the second row of the matrix A. So A1, A2. So this differentiation going to be a column vector of A1, A2. It means that we are getting back this matrix A. What I'm saying that if y is equal to Ax, then del y over del x prime will be matrix A. Okay. I am saying del y over del x prime. This has to be noted that this is del y over del x prime, not del y over del x. Okay. So this del y over del x prime is matrix A. Just see this example for a minute. And if there is any confusion or problem, please let me know. Similarly, if you can check this yourself, that if you want to find del y by del x, so I'm talking about del y by del x, it will be A prime. Okay. So I have just shown you that del y over del x prime will be A, but if you want to find del y over del x, it will be A prime. So you can check this yourself. So does anyone has any problem or confusion so far? If not, then I can move to the next slide. So what I was saying, I was talking about this second item. So del Ax over del x prime is A, but del Ax del x will be A prime. So you can find this out yourself. Okay, it's in the same way that we have done it for this. It's just that here you have to stack the elements, so the partial derivatives with respect to element x in the column form. That's it. So if this is going to be in column form, it means that the whole matrix is going to be transposed. Okay. Does it mean by del x, and then then the second entry will be in the row. So it means that this matrix will be transposed. So it will be a column vectors. So it will be a row vectors. Here it is a column thing. Then it will be a row vector. Let me just check yourself later on. I mean after the class. And if you find any problem, do let me know. Otherwise, it's pretty straightforward. If you understood this, then what I'm saying should be clear to you. Okay, so far we have talked about the linear systems of equation. Now suppose if we have quadratic forms. So we'll talk about a quadratic. We'll talk about quadratic form. So a quadratic form can be written as qx is equal to x prime ax, where x is where x is a column vector and a is a matrix. It is a square matrix. Okay. And then if we multiply all these things, we'll get a system of we'll get a single equation, which will be nothing but summation, double summation xi xj aij, and run j is equal to 1. What I mean. So suppose if A is a matrix, So here I am taking a square matrix. Oh, sorry, a square symmetric matrix. Okay. Here I am taking a symmetric matrix. What I mean by a symmetric matrix? A symmetric matrix is a matrix if if A is equal to A prime, A transpose. So a symmetric matrix A is a symmetric matrix if A is equal to A transpose. Okay. So if this is a matrix quadratic, so we are doing, we are post multiplying it with vector x and pre multiplying with x prime. So if it will just be ax, then it will be a linear systems of linear systems of equation. But since we are pre multiplying it with x prime, so then it will become a quadratic form. Okay. Now since a matrix this matrix A is a 2 cross 2 matrix, so the vector A will be a 2 cross 1 column vector. Okay. So if a matrix A has n cross n dimension, then indeed a vector x will be an n cross 1 column vector. Okay. So x prime will be so since A is a 2 cross 2 matrix, so x prime will be a row vector with two elements x1 x2, and x will be a column vector with two elements again, because x is nothing but a transpose of this row vector. Okay. So x prime ax is nothing but x1 square plus 6x1 x2 plus 4x2 x2 square. This is clear, right? Okay. So if A is a matrix, then its quadratic form is this. Now we have to find the derivative of this quadratic form. So we have to differentiate this with respect to vector x. Okay. So how will we do it? So we are interested in del x prime ax by del x, and I'm saying del x. So it means I am going to start partial derivatives in column form. So del x prime ax by del x1 or del x prime ax by del x2 will be these two elements in the column form. Okay. So just find out the first element. So I am differentiating this quadratic form with respect to x1. So it means 2x1 plus 6x2, and this will be 0. And if I differentiate this with respect to x2, then it will be 6x1, 8x2, because this will be 0. And then we can break this in the sense uh, we can uh, we can write it in this form. So we have just pull out the vector x. Okay. So we can write this matrix like this: 2, 6, 6, 8. This matrix multiplied by vector x. Okay. And this matrix is nothing but the 2 times of matrix A. Okay. So this is what it is, ax. So del x prime ax divided by del x ax. Given A is a symmetric matrix. If A is a symmetric matrix, then del x prime ax by del x will be equal to 2ax. Okay. And suppose if A is not a symmetric matrix, then what will be this expression? Again, let's see through an example. So now suppose A is nothing but a non-symmetric matrix. So it means A is not equal to A prime. So then A will be equal to, so suppose A is equal to 1, 5, 3, 4. What will be its quadratic? So x prime Ax is nothing but a row vector x1, x2, and then this A matrix, and then this column vector with elements x1, x2. And if we solve for this, we will get x1 square plus 8 x1, x2 plus 4 x2 square. You guys can quickly check this. Now we wish to find the derivative of this expression with respect to vector x. So what it will be? It will be this vector and if we differentiate with this, and if we find out the partial derivative of these two expressions, what will of these two things, what will we get? We'll get these two expressions. So the first element is nothing but 2x1 plus 8x2. And if we differentiate this expression with respect to, it will be 0 plus 8x1 plus 8x2. So effectively 8x1 plus 8x2. And then again we can pull out the vector x separately. It will be 2, 8, 8, 8, x1, x2. Now see this matrix. What this matrix is? We can break this matrix into this. And what it is? It is nothing but the sum of matrix A plus A transpose. Okay. So this is A matrix 1, 5, 3, 4, and this is its transpose 1, 3, 5, 4. So whenever A is a non-symmetric matrix, then del x prime Ax by del x will be A plus A transpose into x. Is this fine?
Yes.
So to sum up all these different, matrix different derivatives or matrix differentiation. So from where we started, so suppose if we are interested in finding out the derivative of A prime x with respect to x or x prime A with respect to x, it will simply be a vector A. Okay. Del Ax divided by del x prime will be matrix A, but del Ax divided by del x will be matrix A transpose. In quadratic forms, del x prime Ax, del x will be 2Ax if A is a symmetric matrix. But if A is a non-symmetric matrix, then del x prime Ax del x will be A plus A prime x. Yes.
Ma'am, over here the third conclusion is anyway included in the fourth one, right?
Yeah, effective. Yes. This is the more general. This last one is the more general result. Because if A is a symmetric matrix, then A and A transpose are same. So it will be 2A. So these are the few. So these are the broad results which you should keep in your mind that if we differentiate a matrix or a vector with respect to something, then what it turns out to be. And I have told you what are the logics behind all these things. So far this is clear.
Yes, ma'am.
Okay. So okay. So far we were talking about we were just talking about the first order partial derivatives. Okay. Similarly, we can find out the second order partial derivatives also for all matrices and vectors. The only important thing here is we all know how to differentiate the uh, functions. Okay, I mean if you have a single equation, then of course you can differentiate it with respect to x1, x2, x3, x4 up to xn. Okay, the only important thing in matrix differentiation is that how to stack all these elements. That's it. Okay, so far we have seen that if it's just a first order partial derivatives, then how to stack it and what will be the final answer. Okay, now now we will move on to how to stack the second order partial derivative matrix. Okay, and we all know that the second derivative matrix is known as a Hessian matrix. And what is the notation for it? A Hessian matrix is denoted by uh, letter H, capital letter H. Okay, and we know that how to stack it. Matlab, in general, you must have read it in your elementary mathematics that a Hessian matrix is nothing but this matrix del square by del x1 del. I mean, suppose if y is a suppose if a y is a single uh, is a scalar valued function. Okay, here y is a scalar valued function. I'll just add a line above. If y is a scalar value function and x is an n cross 1 vector, then the second order partial derivative will be this matrix. So what is this first row? This first row is nothing but we are effectively differentiating del y by del x1 with each element of x. Okay. Similarly, what is the second row? The second row is nothing but we are differentiating del y by del x2 with respect to each element of x, vector x. Similarly, this nth row is nothing but we are differentiating del y by del xn with respect to each element of x. Okay. So if we have to write this matrix in more compact form, then how we will write it? So let's start from here. We'll proceed using backward induction. I mean, we'll proceed recursively.